Hello, today I'll be explaining how to do animations in assembly and how to make a assembly drawing on Fusion 360. Now, what is an assembly animation? An assembly animation is very important because it allows you to show your design functioning in Fusion 360 or virtually. For example, in our robot project, I will show an example of my robot using animations. Now, if you look, when I'll open my robot, there are several components that need to move. For example, this bit here needs to slide left and right, this bit here needs to rotate, the wheels need to spin, and needs to go forward and backwards. Using animations, I'm able to show, as an example, the robot using a slider. For example, this. Or I'm able to turn the wheels on the robot. In this case, it's not animating properly, but I'll explain later why this may happen. I also use other different types of animations which are called rigid bodies, which make sure that my model does not move in scenarios that I don't need it to move. Now, how am I making an animation? There are three main animations that you'll need to consider when making your project usually, and that is rigid, rotation, and slider. Now I will show an example on each on how to make one. Number one, rigid. Rigid is when you don't need your components to move. For example, when you're creating a chassis of your robot using nuts and bolts and making sure that these pieces are staying solid. It's probably the easiest animation to get your head around because it's not actually doing anything. All you need to do is join two pieces together, set them in the position you want. When you go into motion, in the motions tab, you select rigid. When you select rigid and you move your entire design, what happens is that everything is moving as one. So if I was to move these two beams, they are now basically connected and are inseparable. So I cannot rotate this without the other one rotating. The second animation I'm going to show you is rotation. This is useful for when you're making a wheel or a rotating beam. So to do this, I'm getting a joint. Same thing as last time, joining the two pieces together and choosing the motion revolute. As you can see, this now allows this piece to move around. If you want to see where your component is moving and you want to see it move more, you're clicking on the animate button, and this will animate your component doing the same rotation again and again, just to check if you need this one. You're also allowed to rotate along different axes. Of course, this would be an impossible rotation as long as this one, but if your rotation is incorrect, you can always change the axis. In this case, I would probably use the Z axis. When you're finished with doing a revolute, you're allowed to actually select this little flag and move your design around without actually affecting anything on the assembly. As I said, this is useful for making wheels or for making a beam that needs to revolute around a point, for maybe a robot arm or something like that. The last example I will be showing you is a slider. In this case, for these two components, you want them to slot into each other like this. You will also go on your motion tab and choose slider. As you can see, my own is sliding in the wrong direction. I'm going to choose the y-axis, not the y-axis, the x-axis, which allows it to slide in the direction I want it to. Same thing with Revolute. The slider animation can be played and paused to check if it's the correct one. And once you're finished, it allows you to slide your component left and right. The good thing about all of these animations is that you can connect more and more components to it without actually impacting the animation too much. So for example, in this case, I can connect any component to it, like another beam, like this. I would make the motion rigid, which joins them together, and then, selecting on the rotation, now both pieces are moving in unison, because these two pieces are rigid, and this is a revolute animation. Same goes with the slider. I can now connect a piece to the slider, which is rigid, like this. Oops. And if I'm making the animation rigid, these two pieces are now joined. And I can also use the slider with both of them in action. As I showed you in the example previously, these animations can be used to good effect for simulating your device. So in this case, this thing moves my slider left and right. And as you can see, now everything is moving left and right. Or, in this case, this piece is moving these two around. So if I'm selecting on the rotation, I can move them around like this. And that is the basic principle of making a animation for your design. Next, what if I want to make an engineering drawing to the BS8888 standard? Now, what is the BS888 standard? The BS888 standard is a standard of drawing that you use for making engineering drawings. The way it works is that you're going to have a top view, a side view, a top view, a front view, a side view, and an isometric view, along with information in the corner. This drawing will also have dimensions, usually, for your design, and I'll quickly run you through on how it works. So say now, I want to make this a drawing. What I'm doing is I'm going on File, New Drawing, from Design, selecting my design, Full Assembly, Create New Drawing, From Scratch, Standard ISO, Units, Millimeters, and the sheet size A3. When you press OK, it will take you to a new tab and you'll be prompted to place your design first. This is the base view, or the front view in this case. So when you are placing it, you'll place it somewhere where you can accommodate all of the drawing. So in this case, I'll place it here. Now, when you select on projected view, you can now click on your original design and you can move out. So this is the top view and this is the side view. Once you press create and continue, you have an engineering drawing of the components you need. Also, if you press on projected view and move out diagonally, you'll get an isometric view. In this case, I want it from the top down, like this. The good thing about the isometric view is you can just drag it around, like this, and place it wherever you want on the sheet. It's important that these three are in line with each other. Now, how do I add dimensions to this? To add dimensions, there's a Dimensions tab, and you're clicking on Dimension. With the Dimensions tab, you can get dimensions of straight lines, of edges, or you can create a custom dimension by clicking once and clicking twice on another point, which will give you a custom dimension. The best way to do dimensions, though, is find a flat line where you want your dimension to be, or find two edges that are straight of each other, like this. Dimensions also allow you to find the radiuses of circles or diameters of circles. So in this case, for this curve here, it's an R6 curve. Or for this hole here, it's a diameter 4.1 hole. And like this, you're able to find a lot of dimensions of your components. Of course, it's not going to be as simple as this because your design will be more complicated, but that's the gist of it. Additionally, you'll have a box here in the bottom where you might need to fill it in with information. So, you'll have information such as department, technical reference, created by, your name and date. Do not worry about some of these tabs, like this, you're probably not gonna need to fill any numbers. Drawing number, you can just put in a text of 1, because it's your first drawing. Date of issue does not really matter unless you want to put the date. If you have multiple sheets of your drawing, you will keep them here. The title is here. And also, you're going to need to add a symbol, which is this. Something that looks like this. 1 second. If you look closely to this drawing, oops. Open image. You'll see a symbol here. This symbol dictates what orientation everything is in. You'll want to add a symbol like this, which means third angle projection. Third angle projection is used in the UK for the BS8888 Standard. The third angle projection, as you can see, is like what I did previously. So we have our front elevation, end elevation, and the plan. So the top view, the front view, and the side view. In the first angle projection, it looks a bit different. Make sure it is a third angle projection, because this is what we use in the UK to the BS8888 Standard. Apart from that, that is the simple gist of making a drawing. You will have extra tools, such as these, which allow you to add notes. So for example, a note that I would make would be that the material is aluminum. Otherwise, to other designers, you would say, you'd highlight issues, such as over here we have a collision. And this is the method of how we would go through and improve our design. So in this case, this geometry is impossible, a note would be added, there's a collision, someone would fix it. You can also insert images to your thing, for example the third angle projection image symbol, which you would put here. And you can also export your drawing as a PDF. Otherwise, that is how you make a engineering drawing.